All right, distributive property. So if you remember, way back when we did integers, so positives and negatives, and we kind of talked about you can turn any subtraction problem into an addition problem. So when I see that, yes, I'm thinking -6, but like that's really subtraction right now. So, and I'll be honest, I still, just by all my math experience, I still, in these like, wait, what do I do first? And I see, and then that, and then I get all confused and whereas when it's adding, it's so much easier to feel comfortable like setting things aside and saying, well, I can figure out all this and then add the 2 later. So this is how we are, this is just review from integers just because it was a long time ago we did that. But basically we can always change subtraction into addition as long as, give myself some more room, as long as we change whatever comes right after it, which in this case is the 6, to whatever the opposite sign is. So it's positive right now, right? When it was -6, it was minus +6. But now we're going to change that to plus and we're going to switch this to negative. So now technically 2 plus -6 times all this stuff is the same as 2 minus 6 times all this stuff. It ends up being the same. So for me, this makes it a little more comfortable. So then let's say I rewrite it and I say, okay, cool. 2 plus, and I'm going to change this color so we can talk about the distribution part of it. And then times -5t plus 1. So that part stays the same. Now, for me, I'm much more comfortable with like, that's a negative times that, then like, wait, am I subtracting? Because then I think, okay, well 6 times 1 is positive, and then I have to still subtract the like, I don't know, for some reason it's harder for me personally to keep track of negatives and subtraction at the same time because the symbols are so the same. So if you can turn it into all addition but just with negatives, now that's not subtraction, you just have addition and you have negatives to mess with. So the whole thing about the distributive property, which we've been talking about for a while now, over the last couple of years, I know it's a big middle school concept, is this idea of we basically have that part which we're going to kind of set aside. And then we have this, so actually, you know what, I'm going to set it aside over here. Let's just set it aside for a second because I got to deal with this whole chunk before I can add. This is multiplication and this comes before the addition part, so like that's less important right now. Then I can take my 5t, add and plus 1, and now I'm multiplying this -6. Now the distributive property tells us that this -6 is getting distributed or multiplied by everything up in here. So not just the 5t, -5t, and that's the biggest mistake students make with this. So a different way you can think about it is that 6 goes to all of these, so you can almost like, and it's a negative, it is -6, think about it like 6 times that and then 6 times that, if that's helpful. So basically this guy has to go to both of those pieces. So then I would say to myself, okay, -6 times -5. If you remember, our negative times a negative equals a positive. So we end up with 30t from this multiplication. And then we do this multiplication, which is -6 times +1, which ultimately ends up just being, right, plus -6. Now we can worry about this little critter and bring him over. Actually, 2's our female. Me and my brother had that discussion once, is have you ever thought about if numbers have genders or not? And like obviously they don't, but it's just all in your perception. So in my mind a 2 is actually, anyway, sorry, not important. All right, so now I've got 2, which is a constant, and -6, which is a constant, and then that's my only value, my term that has a variable. So that guy is just done. It's just 30t. But then I can combine basically these two and say, well, if I have 6 negatives and 2 positives, then I can basically make 2 zeros with those, and I'm left with 30t minus 4, or which is the same as 30t plus negative 4. Okay, so I like to turn everything into just addition with negatives, because then I only have one set of rules to remember. Cool, a negative times a negative gives me a positive. Negative times a positive gives me a negative. These two are constants, so they can go together. And if I have 2 positives and 6 negatives, I'm left with 4 negatives, or, which is the same as subtracting out 4 positives. Okay. So that integer, getting comfortable with those negatives and positives and where they go and all that, will help with this. So just reviewing those rules, which are pretty straightforward, and we practice them a lot, so I know that it shouldn't take much review for you to remember those guys. But that's the answer I got, and I noticed it was on your list there. And this whole thing works whether these are whole numbers or decimals or fractions, right? So if they're decimals, multiply the decimal, and you can do that on a side piece of paper. Honestly, by 8th grade, you can use a calculator for that part. I think in Mr. Rosso's 7th and 8th grade classes, they use calculators for like everything, and I think that's what you'll see in high school. So especially when you don't have as much support with, not being in class and everything, please feel free to use the things that you like calculate. This is not practicing multiplication, right? This is practicing a lot of algebra. And so the calculator can just help you get this down faster. Even if you type in -6 times -5 to get those values. Remember, when this is 5t, that coefficient, you just multiply the numbers together and then the t just stays the same. So -6 times -5 is 30, and then this was a t term, so that's a t term, a variable term. Yeah, so hopefully that helped. Again, tomorrow I'm going to try to make more videos that kind of go through the lessons and find decide what videos would be the most helpful for you guys. And then, because I think you're the only one who's actually done the Khan Academy so far, so thank you. And I miss you guys, and hopefully we can do some more math together virtually from afar. All right, cool. Let me know if you still need help. Thanks.